Hey guys, I had a customer ask me for if it's possible to integrate an Aim MXG into a RacePak SmartWire system. So as you can see, I got the SmartWire system here. I have a CAN analyzer, which I'm going to be using for transmitting the messages. I use the CAN output on the Aim MXGs or the Aim CAN outputs all the time, so I know that they're reliable and work. So we're not going to be testing with that, just to keep the amount of things that I have to manage as small as possible. So just a quick overview. We got the SmartWire set up from RacePak. We have a switching mechanism. It's like a membrane keypad that you have here. Seems to be working. And then we have their VNet. The VNet that we have is, it looks to be like adult Legos, I guess is the easiest way I can explain it. All I've done so far is I have taken my power supply, hooked it up to the battery input pin, and then or the battery input post, and I grabbed the ground from the from the headers. So now the system's on. It's plugged in via my mini USB cable, so mini USB to USB, and then he has now I have a RacePak Universal EFI CAN interface. So this thing right here is going to be required for something like this. The VNet is not very flexible. You need an external device to make any additional info that, like, to grab not AEN or not RacePak specific stuff. So it's just like this universal CAN adapter is what it looks like. So I have that basically connected via CAN high and CAN low. It's only got 2 wires on there. It's pretty straightforward install. So what I've done, funny enough, I actually was doing this for the first 8 or 9 minutes, and the video camera wasn't even recording. So I've already got a head start on you guys, but we'll go over some of the things that I did initially. Quick recap. We go to ECU type, set it to user configured, send the transmission, read it from the hardware. Wait, EFI setup. Go to number of channels. We want to output 10 channels of information. Set the bus rate to what is appropriate for our settings. In this application, it's 500K. Set the terminating resistor to the on. That is really up to you. If you have external resistors, it's something that you'll have to manage. Easily testable. So the CAN bus with everything connected and powered on should have a nice 60 ohms of resistance between CAN high and CAN low. And you get that by having a terminating resistor in one device and a terminating resistor in another device. 120 ohms at each side. Anything in between does not need a resistor value. So we send this to the hardware. I'm not concerned with transmitted messages. We send this over to it, send configuration, and then we can have our 10 channels of data to process. So set the sampling rate to 20 hertz, set the message at 100,000. In this case, I chose a 29-bit message so that there would be no conflict with the ECU that I plan to integrate it with as well. The extended message format, I set it to 29 bits to make sure that it had enough room for this 100,000. And then I set my Indian type to big. And then I set, these are basically set to off. We're not using any of these. They're row counting mechanisms. And then the message data byte, this kind of threw me for a loop, because it was it asked me to place the byte where the smallest incremented information would be. That's your 1 position, your 10 position, and I just don't understand the need for it. I've already assigned Big Indian and I have my bit offset here, but threw me for a loop. I had it set at 0, but it did need to be set to 1 in this case. So we're sending 2 bytes of information, byte 0 and byte 1 of CAN ID 100,000. And the low byte of data is byte 1, not byte 0. So switch that up, and now everything seems to be working as intended. The bit offset, since we're using byte 0 and byte 1, is set to 0, and it's a true 16-bit message, so we're sending it in a word format. So we're using whole bytes here. Let's not reinvent the wheel. Now that that's done, I went to my output control. I set my on condition for greater than 190 and then to turn off at 170. And I can go in and set my values. So as we can see, I'll pull this over to here. As we can see, as I go up to 190, we'll just do 191. Well, that should be on, shouldn't it? Hardware is not having fun today. I'm using a cheap USB-C controller and it's not working well for me. Okay. So let's try this again. We'll set this to, first we'll make sure that the hardware is off, so we'll send 160. Validate that the hardware is off. Perfect. Now we will send our command value of 191. Should enable the output status to on, and then we will check the off status by going to 170, and now the hardware is off. So everything is being interpreted correctly. Now we'll switch over to now that, I mean, that's, you would just basically fill this ECU, these ECU channels here with the pertinent information that you want to control all of your outputs. So in that case, it's really just a rinse and repeat. Now we'll go to our hardware setup, and let's say I wanted to output this on CAN 1 or CAN 2, depending on what I have access to and what's required. The output's really simple. All we have to do is do a payload here, and then we have our ID in hex, and we just enter in our value of 100,000. The little cursor there. So we're outputting our CAN ID of 100,000. We go to Big Indian. I'll eventually use all 8 bytes, so I'm going to set that up, and the frequency will match at 20 Hertz. I put that as OK, and I access my first 2 bytes of information. I set the number of bytes here, and I want to use a channel. So for this, we'll go from the ECU, we'll set the water temperature, and I'm going to send it with the same multiplier and offset. I didn't manage those in any special way, so that's a 1 and a 0. I hit OK. Now I'm outputting my data at 500K on CAN bus 1 for water temperature. When the value gets above 190, we will have a activation of the first power distribution channel, and then when it gets below 170, it will deactivate. And that's it, guys. That is a full installation. I mean, I know it's only one channel, but you would just extrapolate that out to almost anything that you could possibly want to do. Just make sure to manage the bus speed correctly. That's probably the biggest hiccup, is people not managing the bus speed. And then you have small things like the asking for the low byte. If it's in Big Indian, it is the furthest right byte on the byte map. So this would be the low byte of information. This is where your small digits are going to happen, your decimal places, your 1 position, your 10 position. And then this is where your large information. So if you think about the way a number is written, we read 100,000. The low byte would be here. The high byte would be here. And that's really it. If you guys have any questions or comments, let me know. This is my first video of helping. This is the stuff I do every single day. So if you like the content, let me know. If there's something that's very specific, give me some ideas what to make videos of, and I'll try to get them. If you like what you saw, go ahead and subscribe, and we'll hope to get more content for you.